Hi. Yesterday, Joranalogue posted another Tech Thursday video, and in this video he used Select 2 to perform ring modulation with Generate 3. A screen captured a part of that video, so let's have a quick look at that.
Hi, it's Thursday, or better known in the Joranalogue corporate hours as Tech Thursday. My name is Jono, and today we're going to use Select 2 as a ring modulator.
Now, unfortunately, I don't have a Select 2, so I cannot build the patch like Joran did in the video. But what I can do is show you a few things about ring modulation and amplitude modulation, and how you can just use a Generate 3 to perform ring modulation. So let's dive in and modulate some ring. In this patch I'm using two generates. For the moment I'm using the even output of the rightmost generate, and this is visualized as the bottom trace here. The top trace, well, the blue one, is the core output of the leftmost generate 3 here. Let me turn down the level a bit so it's a bit less harsh. And you can just use these harmonic inputs here to ring modulate them with another, well, usually a VCO. And despite these thousands of cables, I just want you to focus on these two traces, which are just the outputs of the generates. And I'll connect the blue trace here, the triangle core from the left one, to the even harmonic input here on the right one. And that's really all you need to do to perform ring modulation with Generate 3. Now I use two Generate 3s, but you can just use one Generate 3 and, well, connect some kind of other VCO into one of these inputs. That really doesn't matter. But let me turn down the frequency of the left Generate 3 here, which is still the blue trace. And this will help you visualize what ring modulation is doing to a signal. So now that I've turned down the frequency of the left Generate 3, which is still connected to the even input here of the rightmost Generate 3, and we're also monitoring the even output. Connecting anything to any of these inputs does not affect the other harmonic generators. So when we are sending something in here, we are not going to get ring modulated signals out of the fundamental or the odd outputs. So like I said, here you can see what's happening. And usually, well, when we're talking about the difference between ring modulation and amplitude modulation, usually the difference, well, in practice comes down to what kind of VCA you're using. A 4-quadrant multiplier or a bipolar VCA is usually associated with doing ring modulation. And a 2-quadrant multiplier, aka a unipolar VCA, is usually associated with amplitude modulation. But what I want to show you here is that you can do amplitude modulation with a ring modulator or 4-quadrant multiplier just as well. What you need to do to get amplitude modulation out of a 4-quadrant multiplier is just make sure that one of the two signals that you're multiplying together, which is what a VCA does, that one of those signals is not a bipolar signal. For this I have routed the core output of Generate 3 through bias 2, and if I then remove the signal that I've connected to the +5 input, the +5 volt normalization in this circuit makes sure that the bipolar triangle core of the leftmost generate 3 is pushed above 0. So where it was oscillating between 5 volts and minus 5 volts, it's now oscillating between 0 and 10 volts. So it's still a 10 volt peak-to-peak signal, it's just offsetted with 5 volts. And well, most importantly, what you can see now is that the saw wave coming from the right generate 3 is not getting inverted. When I reconnect the cable to the plus 5 input on bias 2 and there's nothing happening on the other side of this cable, so I'm sending in 0 volts, then this normalization is overridden. And then once again, we're just sending the core output of the leftmost generate 3 to the even input just as it was, a bipolar signal. And then we can see that we are getting inversions of our saw wave. And this is happening whenever this very slow triangle drops below 0. Now if we increase the speed of this left generate here to audio rates, it's a little bit fast to see, but you should be able to notice that there's something, well, kind of weird going on with the wave. And this is because it's getting multiplied with this signal and it's getting inverted in the process. Now, again, when I remove this cable from bias 2, which is now offsetting the triangle here with 0 volts, if I remove this, we're offsetting the triangle with 5 volts, then we're getting a different kind of signal here at the output. And by the way, for the moment, I'm just monitoring this even output here, the red signal. But let's now do something creative. This cable is not dangling here for no reason. So when I connect this signal that's offsetting our triangle wave to a manual offset, you can see and hear that by increasing the offset, we change the timbre of the sound, and that's because we're kind of morphing between ring modulation, which is just giving us sidebands, we're morphing into amplitude modulation, which gives us the sidebands and the frequency of VCO that is now called the carrier. If we look at this on a spectrum analyzer, which luckily for me data provides, if I turn down the manual offset to 0, and at this point, if you remember, the triangle core from generate 3 is not being offsetted before it's sent into this 4-quadrant multiplier. So we are getting ring mod, and we're just getting these 2 peaks here on the spectrum analyzer, which represent the sidebands, which are the sum and the differences of the 2 signals that we are multiplying together. And then if I turn up the manual offset, you can't see this, but you'll see on the spectrograph that there's a signal at the center, which is now very apparent. And well, we're still having the same sidebands, but now we are amplitude modulating, so the frequency of the rightmost generate, which is sending out the saw wave, the frequency of this one is also present at the output. So again, ring modulation, amplitude modulation. Let's go back to oscilloscope view. Now, instead of using a manual offset, you can use something like an envelope to push this triangle core above 0. And this can give, well, at least I think that this gives interesting results, which are completely unique to, well, using ring mod and amplitude modulation. So I hope by showing you this that you, well, first of all realize that you can do ring modulation with just one generate 3. Of course you need some kind of second oscillator, but this can be anything really. And you can just use these harmonic inputs for ring modulation. And like I showed you, you can do amplitude modulation as well. And you really can just use about any Eurorack mixer available. The ones that are DC coupled, which means the ones that accept slow CV signals and don't filter them out. To mix an audio rate oscillator with some kind of slow moving offset, like the envelope that I'm using now to push the triangle chord above 0. It wouldn't be a Tech Thursday follow-up video or follow-up Friday. Thanks for that suggestion, Wolfjoy. It's just too catchy not to use. So it wouldn't be a follow-up Friday if I hadn't built a complete patch around this idea. So let's first of all start off by connecting some sequences to my VCOs. Then I want to switch over to the fundamental output here. Which is a little bit less harsh, as you can hear. I really like how this sounds. And then, well, another feature that's highly underrated is sync. And I will use the flip input on the oscillator that's providing the triangle to sync it to the core output of the right generate 3, the one that's now providing the sine wave. I think sync is something that we all should use way more often. Anyway, let's add a kick drum. I hope you enjoyed this follow-up Friday. Thank you very much for watching and listening. I hope you learned something. See you next week. Bye.